So we're going to go over the second part of our angle basics, okay, starting with radians. Okay, so basically a radian measure. Okay, radian measure is a second way to measure angles. This type of measure is especially useful in calculus. Okay, and also since it's especially useful in calculus, we use it a lot in physics as well. Okay, so a lot of the sciences use radian measures versus degrees. Vectors, not so much in physics. They still tend to use degrees, but in the higher level ones, when we talk about dynamics and in statics, we tend to use radians. Okay, so to define a radian, you can use a central angle of a circle, which is one whose vertex is the center of the circle. Okay, so this picture's got a circle, and the central angle is in standard position. Now the radius right here, this radius goes from here to here. Okay. Also, this distance right here is the radius as well. So this same distance that's from here to here is also this distance from here to here. Okay. So what it's saying is if this is 1, then this is also 1. Okay? You with me so far? Okay, so this is how it starts. So when you're defining a radian, it really comes from this. If you actually take that idea and you say, okay, my radius is from here to here. This is my radius. And you start taking this radius and you go, okay, I'm going to measure the rest of my circle using my radius. So here's another radius from here to here. And then here's another radius from here to here. So this is 1 radius. This is 2 radius. This is 3 radius. Okay? This is 4, 5. This is 6 right there. Okay? So we end up basically getting a little more than 6 radius all the way around. And here's the other thing. It doesn't matter how big r is. It doesn't matter if r is 1, 2, 3, 4, 5, because if the radius increases, the actual distance around also increases. Okay? But let's look at this real quick and let me show you. If you look starting at 0 right here, we end up with 1, 2, 3 radians before we almost get halfway, right? I'm going to let you know that this little distance right here to this point right here is 0.14. Which means to get halfway around the circle, how far do we go? 3.14, which is pi. And if we keep going, this is 6, and this little piece right here is 0.28. So all the way around is 6.28, which is 2 pi. Okay? That's where this idea that 360 degrees is the same thing as 2 pi. Because going 360 degrees all the way around is also the same as going 2 pi radians all the way around. So one rotation around the circle is the same thing as 2 pi. Okay? So when we talk about complete revolutions, they correspond to the circumference and the arc length of 2 pi. So we get this idea that basically 360 degrees is equal to 2 pi. Now, some other important angles are shown in radians in terms of pi as well. So when we look at our circle, we also think about 90 degrees. Well, 90 degrees is half of pi. 180 degrees is the same thing as pi. 270 degrees is the same thing as 3 pi divided by 2. Or think of it this way. If 90 degrees, this is half of pi, right? 1 half. This is 2 halves. This is 3/2, this is 4/2 of the circle, or 4/2 of the pi, which is the same thing as 2 pi. 4/2 is 2. So you can think of it that way as well, okay, using the quadrants. So these numbers are going to be important. These are what we call the quartiles, or the quadrantal angles, the quadrants 1, 2, 3, 4. Okay, these are the most important angles on the unit circle, or on any circle. Now, so angles can be measured in degrees or in radians. Okay, how you're going to know is basically if there's a degree symbol, that is a degree measure. If there's no degree symbol, then it's automatically considered a radian. Okay, so that's why it's going to be important that you guys are making sure that you write down your degree symbols. So when you label your answers, if it's a degree measure, it better have a degree symbol. If not, it's considered a radian. Okay, so this idea of radians makes it a whole lot easier. Okay, so if there's no units of angle measure, it's specified as a radian measure. So if you write theta equals 2, you're implying that that's 2 radians, not 2 degrees. Most radian measures we work with will have pi in them, okay? Because technically, if we deal with radians, and since they come from the 2 pi, there's going to be some rounding errors. So it's always going to be an approximation. So it's easier just to leave them in terms of pi. Now, to convert degrees to radians and radians to degrees, we use this basic relationship that pi radians is 180 degrees, or the fact that 2 pi is 360 degrees. So we actually go back to geometry when you learn proportions and cross multiplying, and we set up a proportion basically like this. We say, okay, well, to convert degrees to radians, right, we use this idea of pi over 180 degrees is going to be equal to whatever radian measure over 360 degrees. Okay, or whatever your angle measure is here. And we could put theta. I'll put theta there. So this is the angle that you're given. This is the angle you're trying to find. So when you cross multiply, you're going to take your angle measure, multiply it by pi, and then divide by 180. It's basically just taking the proportion and changing it to an equation. Okay? So if you're starting in degrees and you want to turn it into radians, you multiply by pi over 180. If you have it in radians and you want to convert radians to degrees, then you take your radian measure and you multiply it by 180 degrees over pi. Okay? Now, this actually goes back to something that you learned in chemistry that you absolutely dislike. Okay? It actually goes to this thing. So if you have it in degrees, you multiply it by pi over 180 degrees. And degrees divides out with degrees. Do you remember stoichiometry? That's basically what we're doing here. It's just a glorified proportion. Okay? So don't get all freaked out. So that's what we're doing. It's a super simple equation. There's not much to it. Okay? So common radian measures that we're going to be using is this idea of 2 pi is 360 degrees. Okay? So 1 full revolution is 2 pi, which means a half a revolution is 2 pi over 2, which is pi radians, which is 180 degrees. Okay? A quarter of a revolution around the circle. Since 1 full revolution is 2 pi, divided by 4 is pi over 2, which is 90 degrees. A sixth of a revolution is 2 pi over 6, or pi over 3, which is the same thing as 60 degrees. Okay, these common angles are going to be seen over and over again. Okay, and that's why I gave you some of them so you could see. So right here, these are common angles that we're going to be using, that you're going to eventually have just memorized. Okay, you're going to know that basically pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. Pi over 2 is 90. Pi is 180. 2 pi is 360 degrees. These are angles that you are just going to know eventually. Just right off the top of your head, you'll be able to spit it out from memory. Okay? Now, going back to what we did earlier, now we've got to reapply some of the stuff we already learned, like coterminal angles. So we learned coterminal angles yesterday. To find coterminal angles, you add or subtract 360 degrees, right? Well, if it's in radians, you're not going to add and subtract 360 degrees. You're going to add or subtract 2 pi. So this is the exact same equation. The only difference, instead of it saying 360 degrees, it says 2 pi. It's the only difference. And n is still the number of rotations. So basically, we're just going to be adding 2 pi over and over again. Okay? So it's not that difficult. It just, the visual part of it is what you guys are going to have to get over. The fact that we're dealing with fractions. Okay? So, basically, two angles are coterminal if they have the same initial and terminal sides. For instance, 0 and 2 pi are coterminal. Okay? The angles pi over 6 and 13 pi over 6 are coterminal. You can find angles that are coterminal by adding or subtracting 2 pi or 1 revolution. And that given angles have infinite number of coterminal angles. And we'll get that to later. Okay? For instance, this pi over 6 is coterminal with all angles where we add or subtract 2 pi n. I just put the n in the middle. Okay? So there are actually infinite number of coterminal angles for any angle because the circle is a loop. So it can go over and over and over and over and over again. It's kind of like the Bible says, there is no beginning, there is no end to a circle. That's why it's used in certain instances as a symbol. Okay? So, let's do some practice. Give me two coterminal angles, one positive and one negative with pi over 2. Okay? So, again, we're just adding and subtracting. In this case, we're adding or subtracting 2 pi. So my first one is going to be 2 pi plus, pi over 2 plus 2 pi, and pi over 2 minus 2 pi. Okay? Now, before you can add pi over 2 and 2 pi, when you're adding fractions, you have to get common denominators. Okay? So that means that I have to change this 2 pi to have the same denominator as pi over 2. Well, that means that I'm going to multiply the top and the bottom of 2 pi by 2. So you're going to get 4 pi over 2. So what's pi over 2 plus 4 pi over 2? 5 pi over 2. Now the great thing about this is that means that once I do the positive one, the negative one is just going to be pi over 2 minus 4 pi over 2. So this is negative 3 pi over 2. It's that easy. Okay? The hardest part about this is remembering that you're going to be adding and subtracting 2 pi and then getting common denominators. Okay? All right. The next one. pi over 12. Okay? So we start by taking pi over 12 and adding 2 pi, and taking pi over 12 and subtracting 2 pi. Same thing. Before I can do that, I got to get common denominators. So I get pi over 12 plus 24 pi over 12, because you got to multiply the top and the bottom by 12. And then I'm going to take pi over 12 and subtract 24 pi over 12. And if you have 24 pi's and you add another pi, you have 25 pi's over 12. If you have 1 pi and you subtract 24 pi's, you got negative 23 pi over 12. That's the way it works. And the last one, negative pi over 4. So negative pi over 4 plus 2 pi, and negative pi over 4 minus 2 pi. And again, we got to get common denominators first. So pi over 4 plus 8 pi over 4, and negative pi over 4 minus 8 pi over 4. And negative pi plus 8, that's 7 pi over 4. And a negative pi minus 8 more, negative 9 pi over 4. And that's the end. So the only difference between coterminal angles in degrees versus coterminal angles in radians, we're still adding or subtracting 1 revolution. We're just doing it with either 360 or 2 pi. So that's one of those things you're going to have to just remember, that they're the same.